the acceleration is the same. So I'm going to tap there for all the same. Same. And there we go. We got them right. Yay. So let's go back to the beginning. We'll do another one of the second set. Okay, so here we go. Ball is launched upward from the ground. Its location at 1 second intervals is shown. Set of velocity and acceleration vectors is shown for location 1. Okay, so we have happening here. If you check out at position I, rather, the acceleration is down. It's always down. Gravity is always pulling down. And the velocity is down at I. Why? Well, because they threw it up at position A. This should have an up vector here. And of course, the velocities are getting smaller and smaller and smaller as you go up, eventually reaching 0. So this red arrow down here that represents velocity, over here would be the same length, but in the opposite direction because the ball has an upward velocity. Then the arrow gets shorter, and then shorter, and then shorter, and then there'd be no arrow for velocity. It'd be so small here. Then it'd get a little longer, but pointing down, and then longer, and then the longest. So we're trying to match 3 of 6 provided vector combinations to locations B, D, and G. So drag the correct vector diagrams to the correct spot on the diagram. All right, so for B, what we know about B is that the ball has to be going up. So we can get rid of these 2 down here. They're not going to work. That one's not going to work. So our choice is this guy here or this guy here. What do you think? Is it going to have a big velocity at B or a small velocity? Here's a small velocity. Here's a big velocity. Well, remember, you've got to throw it pretty fast, and then it gets slower and slower and slower and slower. So it still has to have a pretty good velocity at position B, and it has to be going up. So this works. Also, check the length of that velocity vector compared to the length of this. At position A, these 2 vectors should be the same length, but in opposite directions. At position B, this should be a little bit less velocity, a little slower here, and that makes sense. This vector is a little smaller than that one. So I feel good about this choice. How about D? The object is still going up, but it's going very slowly because it's almost at the 0 velocity point. Remember, the acceleration doesn't change ever. It's always downward because of velocity, and it's always 9.8 meters per second squared. So at the top, upward velocity, very small, same velocity. This fits the bill. And if you think about this, it makes sense. The velocity was big, a little smaller still, and then 0 there. Still going up. But now these guys, F, G, and H, need to be going down. So they need a downward velocity vector. So we've got 3 to choose from. This little dude here, this longer dude there, this middler dude here. Well, we got to think, which of these makes sense? Look at the length of this vector. It's the same as that. So this one would have to go there, and that's not what we're being asked to do. So this can't be it. How about this little dude? No, that's not it. It's got to be downward velocity. Oh, look, that does it. And check out the length of the vector. That velocity vector is longer than this one, which makes sense because if these are equal and opposite, if this set of vectors represented F, these 2 velocity vectors would have to be the same. But remember, things speed up going down, so it's going to be a little longer velocity vector at position G. Let's see if that worked. Hold on, where's my check answer? Yay, we got it right. Now let's get to the hardest stuff, the one that was really causing some people some problems over here. Let's keep it simple and go with gravity is -10 meters per second squared. Okay, this is not the hardest one. We'll do another one in a second. All right, so we launch it upward at 30 meters per second, and the location is shown at 1 second intervals. So if we launch it upward at A, that's going to be upwards 30 meters per second. And the acceleration is always -10. Just go ahead and fill these in. Remember, the acceleration for any object in the air with gravity operating on it is gravity, which is -9.81 meters per second squared. But you're allowed to use -10 in situations like this because it's about the same number. Okay, so we've got the accelerations dealt with. Now let's talk about the speed of this object. If it starts off 30 meters per second, gravity is going to steal 10 meters per second, so a second later, it's going to have to be 20. Not -20 because it's going up. And then 10 because it goes from 30 minus 10 is 20, minus 10 is now that's got to be 10 in the upward direction. And then at the very top, at the top of any object's trajectory, the velocity is always 0. And then you get this nice symmetry. On the way down, it's still losing 10, so it's going to be -10. 0 minus 10 is -10. Negative 10 minus 10 is negative 20. So F should be negative 20. And then what we find out is that position G, the object has the same speed but in the opposite direction. And that should do it. Yay! All right, so there we've done a few of all of those. I'm going to pause for a second, and I'm going to tell you about the other concept builder. Okay, so here's the second concept builder, and this one's just as simple, but it's a little trickier to understand what's being asked. So let's go through a few of these. Okay, here we go. Paintbrush is dropped from the top of a tall ladder, and it falls to the ground. What changes would be observed to the velocity and the acceleration of the brush? Well, the velocity, if it's moving down, technically it'd be decreasing, but we know it's getting faster. And they didn't tell us which way is up and which way is positive and which way is negative. So let's just assume that it's going to get faster by saying the velocity increases means it's getting faster. And the acceleration always remains constant, always. All right, let's do one more of those just to make sure we know what we're doing. All right, tennis balls hit straight upwards and then undergoes a free fall motion as it rises towards its highest point and then fell back to the ground. What changes would be observed in the velocity and the acceleration of the tennis ball as it falls downward from its highest point? So we're talking as it falls downward, just like the last one. Velocity increases, acceleration remains the same. There you go. I wish they said the speed and not the velocity. I think they're making it a little bit confusing by talking about velocity because, you know, the sign comes in. All right, so I think you can get through the rest of these, but there's others that are more confusing. So let's take a look at some others that are more confusing. The speedometer one. This one we talked about before. Let's find out. So here we go. This one says it's launched upwardly at 50 meters per second. And then every 1 second you have a new velocity. So let's find out. We know what gravity does. It takes 10 meters per second away every second. So if it's 50 meters per second here, we know that because it says that. Next it'd be 40, then 30, then 20, then 10, then 0. So we're looking at what location will the ball have a speed of 0 meters per second? That's going to be 50, 40, 30, 20, 10, 0 at position F. Ta-da! Plus, we didn't have to do that crazy math. We just know that things have a 0 velocity in the y direction when they're at the top of their trajectory. Let's try this one, though. At what location, so this one's launched up 40 meters per second. And then it says, at what location will the ball be moving downward, so it's going to be one of these guys over on this side, with a speed of 10 meters per second. So if it's moving downward, it's got to be over here. So we know it's going to be 40 meters per second, then 30, then 20, then 10, then 0, then negative 10, negative 20, negative 30, negative 40. So at what location will the ball be moving downward, F, G, G, or I, with 10? Well, we know it's 0, then to 10, so it's got to be F. Yay! All right, let's try another one. All right, here we go. Ball is thrown up 50 meters per second. At what location will the ball be moving downward with a speed of 40? Well, downward is going to be this side. Remember, we throw it at 50 meters per second here, 50, 40, 30, 20, 10, 0, negative 10, negative 20, negative 30, negative 40. Hey, that's what we're being asked about. So J. Ta-da! All right, so far so good. Let's look, see if there's something more challenging yet. Wait, was that it? That's not what I wanted to do. Let's get out of there. All right, let's go to, let's try this guy. It's about time. All right, let's see. Ball is thrown upward 30 meters per second. And then it's going to come back down again. How much time does it take to get from the release location A, where it's thrown, to the highest point? Well, if it's 30 meters per second, it will take gravity 3 seconds to get rid of all 30 of those meters per second. Remember, it loses 10 meters per second each second. So it's going to be 3 seconds to go up. From A to get here, well, if it's 3 to go up, it's going to take 3 to get down for a total of 6. Ta-da! All right, let's try one more. All right, here we go. These are trickier. These are the ones that I found to stump me the most because I was blowing through many of these words and not reading it carefully. So a ball is equipped with a speedometer that's launched, and it's launched straight upward. The speedometer reading 5 seconds after the ball is shown at the right, 10. Now we don't know if that's going up or that's going down. We just know it's going 10 meters per second at that point after 5 seconds. And it says the ball is moving downward. Aha! So from 5 seconds, it went up to the top of its path, and it came down to that 10 meters per second. So at what approximate time would the ball be moving upward and display the following speedometer readings? Let's take this to another place where we can write some things out and make some notes. Here's what we do know, though, is that this ball has been traveling for 5 seconds, and it's moving downward with 10 meters per second. So this ball went up, and it's on its way down, and it has a speed of negative 10 meters per second, and it's been taking 5 seconds to do that. So I like to make a data table. Time, and then velocity. And we know it's at negative 10. That's where we are now, and that is at 5 seconds. How do I know that? Well, it says it's been 5 seconds after the launch is shown, and the ball is moving downward. So that meant that at 4 seconds, it was at the top of its path. At 3 seconds, it must have been going up with a speed of 10. At 2 seconds, it must have been going up with a speed of 20. And at 1 second, it was going up with a speed of 30. And then, of course, I've forgotten 0 seconds, which must have been 40 meters per second. So that means somebody threw it up into the sky, 40 meters per second. A second later, it's traveling 30. A second later, it's traveling 20 meters per second. 3 seconds, 10, at 4, 0, and at 5, it's negative 10. And then 6 would be negative 20, 7 would be negative 30, 8 would be negative 40. Let's take a look at what we're being asked over here. Leave that data over there. That's what I want to do. Okay, so here, at what approximate times is the ball be moving upward? Notice this question is asking upward, and display the following speedometer readings. So upward at 20, well, that's going to be here. That's upward at 20. Remember, the first part of the trip was upward. So I'll say for that one, let's do 2 seconds. And then for this guy, upward traveling 30, well, that would have been a second earlier, because remember, upward, it's losing velocity every second, so that must be at 1 second. And how do I get this again? Well, remember, when we just lost my notes. Writing that stuff out helps. Does that do it for us? Yeah, that does it. Let's do one more to help you with that. Okay, here we go. You've got launched straight upward, the speedometer reading 2 seconds after the ball is shown to the right, and it's still moving upward. So 2 seconds later, it's at 20. At what section or what time will the ball moving downward and display the following speedometer readings? All right, I need to get my notes again, if I can find them. Bear with me. All right, so here's our last stuff. Let's get this out of the way now, and let's take a look at what we're dealing with here. Oops. All right, we know the ball is moved upward, and 2 seconds later, the ball has a speed of 20. So let's do our time and our velocity, and we know at 0 seconds, 1 second, at 2 seconds, the ball has a speed of 20 meters per second upward. That's what we're told in the data. At what approximate times will the ball be moving downward with these speeds? Well, a second later, it'll be going 10 meters per second. A second later, it'll be traveling 0, so it reaches the top of its path at 4 seconds. Then 5 would be negative 10, 6 would be negative 20. So here, if it's moving downward at negative 10, that's what this first bit is asking us over here. That's going to be, shoot, what time did we just get? Where'd my stuff go? Where'd my notes go? We can see that it's at 5 seconds. All right, now let's take a look at the other one here. Let's see if we can drag this over to the side a little bit. There, that helps. All right, so this guy here, what are you doing? Come on now. We're looking at 20 meters per second, and again, downward. Well, it's going to be a second after this one, because remember, it gains 10 meters per second heading downward. So it's going to be 6. Here we go. All right, folks, so hopefully that's enough to keep you moving forward on these. If you have specific questions, if these didn't help and you're still stumped, hit me up and I'll help you out.